In a successful VFX shot, a 3D object shouldn't slide or jitter against the background. Instead, it needs to behave as if it actually occupied the physical space where the camera is moving. After Effects has an incredibly powerful 3D camera tracker, but taking that specific tracking data and moving it natively into Blender's 3D environment is notoriously difficult. The solution is a 5-minute pipeline that relies on 2 free scripts, an exporter for After Effects and an importer for Blender. To follow along, you need After Effects version 2022 or newer and Blender 4.2 or newer. Mastering this data bridge removes the software barrier between these two programs. It gives independent creators a clear path to professional-grade compositing. Step 1 is inside After Effects. Apply the 3D camera tracker effect to your footage layer and make sure the detailed analysis setting is enabled. Once the analysis is complete, tracking markers will appear. Hover your cursor over these markers to find a grouping that sits on a consistent, flat surface in your shot. You must select exactly 3 tracking points on that same physical surface. 3 points define a proper geometric plane, giving us a stable foundation. Right-click your selection and choose the Create Solid and Camera command. Scrub through your timeline to verify the track. If the colored square, the track solid, sticks perfectly to the background without drifting, you have a successful solve. This specific track solid is necessary because it serves as the definitive anchor point. It translates the 2D pixel coordinates of your video into a 3D physical space that Blender can understand. Next, install the Export Composition Data to JSON script into After Effects. You must completely restart the software for the script to appear in your file menu. Cautionarily, before you run the script, you must select both the 3D tracker camera and the track solid layers in your timeline simultaneously. Look at the Export dialog box. You need to check the box for Export Selected Layers Only and intentionally leave the Bake Transforms box unchecked. This prevents the script from breaking your smooth animation curves. Save the file. If your system defaults to saving it as a text document, simply rename the file extension to .json. This lightweight JSON file now holds all the complex spatial math, Bezier easing curves, and lens data required to trick Blender into mimicking a real-world camera. Over in Blender, start with a completely clean workspace. Delete all default objects, including the camera, to prevent any conflicts with the incoming data. Activate the Import Comp to Blender add-on in your preferences, then navigate to File, Import, and select the After Effects JSON option. Look at the left-hand import panel. Enable 3 specific settings: use comp framing, use comp resolution, and adjust frame start and end. Hit Import. You will immediately see a new camera and a flat plane object appear in your empty 3D viewport. Now we have to fix the frame offset problem. After Effects calculates timeline math starting at frame 0, but Blender begins playback at frame 1. This diagram shows the required correction. Open the dope sheet. Select all the camera keyframes and physically shift them forward by exactly 1 frame. Without this 1 frame correction, the physical motion of your 3D render will constantly slide against the reality of the background footage, which ruins the integration. Select your imported camera, go to the Object Data Properties, and load your original video file as a background image. Select the imported track solid plane and use the Shift-S command to snap your 3D cursor exactly to its position. Add your 3D model, which will drop right onto that cursor location. Scale it to fit the scene, and then safely delete the temporary track solid reference plane. Playback is the ultimate test. If the 3D model stays glued to the moving background without drifting, the mathematical translation is a proven success. To finalize the output, transition to Blender's compositing workspace. This is where we merge the rendered 3D object layer with the raw video footage layer. This node diagram lays out the exact logic required. Use an alpha over node, connecting a movie clip input to the top image socket and your render layers input to the bottom image socket. From here, you can push for photorealism. A great next step is to introduce a shadow catcher plane under your model to ground the object with realistic lighting. If you encounter any API mismatches or frame rate drifting, leave your questions in the comments below, and subscribe for more VFX workflows. Establishing a reliable bridge between your tracker and your 3D workspace allows you to place digital assets into any environment with mathematical precision.